Okay, in this video, I want to establish a formula for the antiderivative of the secant function. So the integral of secant of x dx. And to do this, I'm going to apply one of my favorite mathematical techniques, and that is mathematical trickery. So what I mean by that is we're not taking a standard approach. We have a little tweak specific to this particular problem. Now, what I'm going to do is take this, take the integrand, take the secant x, and multiply by 1. So we'll do secant x times 1. But we'll multiply by 1 in the form secant x plus tangent x over secant x plus tangent of x. And so if we multiply through on top, we'll have secant squared x plus secant x tangent x, all divided by secant x plus tangent of x. Now, why? Why would we do this, and why does this make sense? Well, the derivative of secant x is secant x tangent x, and the derivative of tangent x is secant squared x. So this, using this particular trick, this will allow us to sort of put our integral in the form u prime over u. And now we could use the log rule. So if we we'll make a substitution here. Let's say u is equal to secant x plus tangent x. Then du is equal to secant squared of x plus secant x tangent of x dx. And so with this substitution, our integral becomes du over u, or 1 over u du. And that's very nice, very easy to work with. We know that is equal to the natural log of the absolute value of u plus c. And let's go back to blue. We'll go back to our original variable, and that is the natural log of the absolute value of u, which is secant x plus tangent of x. And don't forget the plus c. Okay, so our formula for the antiderivative of secant x is the natural log of the absolute value of secant x plus tangent x plus c. Let's put that in green. Now, this is not the only method. We could have also used a method called partial fraction decomposition by rewriting the secant x as 1 over cosine x and performing a different but similar in nature type of mathematical trick. It's a bit longer of a process, and it's also a topic you wouldn't cover until Calculus 2. But this is the standard proof. I know in my notes I say view Eric's proof of the secant function. This is not my proof. This is just me explaining a proof that already exists and has existed for a long, long time. Okay, if you want to look at the antiderivative of cosecant x, it's a similar trick. You could try that on your own. Just sort of follow the same format and the same steps.